And earlier, the example we completed on Friday, I did not verify the solution we got. So I'm going to verify that and make sure that actually works out, right? So from the first one, right, left-hand side, right-hand side of the first equation, right, the original, we had negative 3x plus 2y is equal to 2, right? That's straight from the original here. And then you just plug in. So negative 3x is 2, y is 4, and this gives you negative 6 plus 8, which is 2. So left-hand side is equal to right-hand side. Check, right? We're going to break this off and then do the same with the second one. Left-hand side, right-hand side. We have 2x minus 5y is equal to negative 16. And we have 2 times 2 minus 5 times 4. That's 4 minus 20. That's negative 16. So left-hand side is equal to right-hand side. Well, when some of the ACs I've seen, your left-hand side, right-hand side do not add up, like it's not correct. So technically you should have concluded that it's not a solution to be consistent. Most likely you made a mistake, right? And there was the homework for you. That's going to continue. If you didn't do it, then you'll have a do-over. Okay. Just make sure you follow along and think outside the box, right? Don't think it's always going to be this way. This, especially with chapter 6 and chapter 5, right? There's various ways of arriving to the same conclusion, right? So you can just see this as one way of doing it, and maybe doing homework or on your own, you try. It's like, I wonder if it could have worked this way, and if it does, then you know, right? It's consistent. Okay. All right. I'm going to grab a highlighter here. So we have this system here, and I know right now we're working with elimination, right? So the first reason that I would have suggested elimination is because you don't see any variable with a coefficient of 1 or negative 1. So isolating would be a bit more challenging, right? So what we're going to do is we want to try to find opposite integers so that when we add, it eliminates one of the variables. So which one do you want to eliminate? Do you want to eliminate the x's or the y's, right? And maybe just to change things up, I'm not going to focus, I'm going to actually focus on the y's here, okay? So there's a 7 and a 3, right? So if you add up right now, you would not eliminate them. You want 0y if you were to add them up or subtract them, right? That's our goal here. And so what I'm going to do is I'm just going to go ahead and call this the first equation and this the second equation here, right? Those are the original. And I'm going to take this whole equation and this whole equation and multiply by something strategic. So let's highlight, I'm going to highlight the 7 here and the negative 3 here. Okay. So basically just look at the 7 and the 3. If I multiply the top here by, I'm just going to multiply it by 3, not negative 3. And you'll see why in a bit, right? But there's the 3 nonetheless. So we're going to say, hey, I took that coefficient and I used it up here. And I'm going to multiply the second one by 7. Right? So I'm kind of doing like a crisscross thing here. right? And that will generate two of these two coefficients that will cancel out. Right? And so what do we get there? We will, how about we rewrite it next to it here, right? So we have 3 times 6 is 18x, then it's 21y, and then it's 30, right? So you're multiplying everything by 3 up top, and then the second one, you go 7 times 2 is 14x. Just be very careful with signs. 7 times negative 3 is negative 21. There it is. That's what we want. And then 7 times 14, we're going to go, what would make more sense there? We can go 7 times 4 is 28, and then 7 times 1 is 7, plus the 2 here that I carried is 9, so that's 98. Okay. This is just one way of doing it. I know some of you saw a different strategy there, right? So now I'm going to call this equation 3, and this is going to be equation 4, right? Just for reference. And so when we add, what can we do now to eliminate, right? Because plus 21 minus 21, right? Positive 21, negative 21. I can just add them. Okay, important here. I'm adding both equations up in this case. So I purposely did not multiply by negative 3 here, even though there was a negative 3 there, because I could see that they have opposite signs. So let's just keep this positive. If you had put a negative 3 in here, it would have turned this to a negative 21. And if you add it up, then you get, right, you're adding negatives. So to circumvent that, you would have had to subtract the equations, but it makes it a little bit more challenging. So I would always suggest do it in such a way so that you add the equations, right? So here we add, and we have 32x. We have plus 0y, that's what we want, is equal to 128. Okay, so essentially these have canceled out. Where's my red pen? This one right here. So essentially you cancel these out, right? That's basically what we've done, elimination. Right? So we end up with 32x is equal to 128. Divide both sides by 32. And if you think about it, 32 and 32 is 64. Another 64 is 128. So that's right, it goes in there 4 times. So this is your first, right? First step, right? I'm going to go step 1. I create opposite integers. Right? That's what we're doing this. And so plus 21, negative 21 are opposite integers, right? Plus 21y and negative 21 are opposite integers. Okay, so these two are considered opposite integers. That's exactly what we wanted, so that when we add or subtract, you eliminate them. I will tend to make it be in such a way that when you add, they eliminate, right? And then step 2, right? Sub whatever you found, x is equal to 4, into, you can choose 1 or 2. You can go back to the original Mr. Dixon, could I have picked 3 or 4? Yes, you could have, but we tend to go back to the original if possible. Whichever one is easier. In this case, these ones actually have smaller values, right? I choose 2. Let's say I choose 2, for example. Right? I choose my second equation here. So it's 2x minus 3y is equal to 14. In this case, I know that x is 4. Watch your double negatives if there are any. And so that's 8 minus 3y is equal to 14. Watch what I'm doing now. I'm isolating y, right? Because I found x, now my goal is finding y. So the 8 comes over, so negative 3y is equal to, 14 is already there. This 8 comes over subtracting, right? It's positive here, comes over subtracting. Some of you are still getting that wrong. I don't know if you're forgetting, right? And there we go. So that's 6. Divide both sides by negative 3. Y is equal to negative 2. How about this? Right next to it, if you have the room, some of you might be running out of room. What about I choose? What if you had chosen the first one? No problem, right? X is equal to 4 plus 7y is equal to 10. I'm going a little bit faster here. Right, then you have 7y is equal to, the 14 comes over, subtracting. You divide both sides by 7 and you still get negative 2. See how that's how it should be. It should all jive, okay? So now you found the x and the y value of your solution, but you're going to first verify, okay? So we're going to kind of block this off. Step 3, verify. So left-hand side, right-hand side of the first one, okay? So we have 6x plus 7y is supposed to be 10. So 6x, which is 4, plus 7y, which is negative 2. This is 24 minus 14. And yes, it turns out to be correct. Block that off. Do the same for the second one. 2x minus 3y equal to 14. And so it's 2 times 4 minus 3 times negative 2. Oh, there's a double negative, right, that I keep on mentioning. And negative is positive, right? So 14 is equal to 14. Therefore, 4, negative 2 is the solution. There it is, done. I will just make a note here. So this is an important note to make at the end once you've verified. State whether or not it is a solution. Okay. So let's make it verify always unless I tell you otherwise. So if I'm not saying on the question will say do not verify, then don't worry about it. Okay, just move on. But verifying is very important it's very important to make sure you did things right. If it doesn't add up, you got to go back and check, right? Okay. I will make a little note here. No. An alternative strategy that you could have applied was multiplying the second equation by -3, let's say. How so? Well, if you had multiplied the second equation by -3, just focus on the first term here, on the x term. That would have resulted in a -6x here, right? And a -6x, right, would have canceled out with the +6x there. So I will make a note of that. We could have multiplied equation 1 by -3, resulting in a -6x term. This would have eliminated the x variable. Let's just do this variable like that, shorten it. So this would have been an alternative start to solving by elimination, would have been to do this. Okay? And so just to be clear, the way I just solved it, that's just one way of doing things. I don't want you to just think that's the only way. Okay? So the goal here is to eliminate variables however you see fit, right? But the multiplying both equations by the crisscross of the variables always works. It's just might end up being a little bit more work, bigger numbers as a result. Okay. Let's do a question that involves fractions. Not a big deal. We can handle that. Okay. Fractions. What would you do there? Well, in general, anytime you have fractions, we want to try to get rid of it. And that's just done by multiplying the whole equation by the lowest common multiple, okay, of the denominators, that is. Okay. So we're gonna take this equation and we're gonna just say, hey, we're gonna multiply this whole thing by, in this case, 4, because that's the only one that's really there other than 1, right? And so you end up with 3x negative 4y is equal to 8. And then we're going to multiply this one here by 8, right? 8 is the lowest common multiple. And so that ends up with x, right? 8 times 1 is 8, divided by 4 is 2, right? 2y is equal to 16. Right here, right here at this point, I would see, hey, I can solve this by substitution, right? Because you have a coefficient of 1 there. I'm just going to isolate x, plug it into the top one, and then go. I will do that on the blank side. That's just before this question. But for now, let's keep with going with elimination. Okay. But I need you to know that it's all connected. All right. So if you were to eliminate right now, it wouldn't work. Okay. So what I'm going to do is I'm going to multiply both or one of these equations again by a constant to make that happen. Okay. I'm going to multiply the bottom one here by 2. Because if I multiply the bottom by 2, I get a 4y here and I have a negative 4y there, and then they're going to eliminate. You could also multiply the bottom equation by negative 3. If you multiply by negative 3, right, this will cancel out. How about we do that? Let's do that. Yeah, let's focus on x now again. So I'm going to take this one, this whole equation, and multiply it by negative 3. Strategically by negative 3. So that gives me negative 3x minus 6x. Sorry. Yeah. Sorry, I'm just making sure. And then that would be negative 48. Like that. So multiplying this whole thing by negative 3. This one just comes over. Nothing happens here. Just copy and paste, right? Now we can eliminate these two here, like that. If I add, right, I'm going to add this equation and this. Just so you know, I'm going to try to make it so that it's always adding. It is easier to do that. So I multiply by negative 3 strategically. Wouldn't it be 6y? Yes, sorry, thank you. Yep. There we go, thank you. And so change this everybody at home, okay? I don't know if you're looking up on your screen, but this is y here, not x. So for a negative 4 and negative 6, that's negative 10 y. And this would give you negative 40, right? And then you divide both sides by negative 10. And so y is equal to 4. So we've got y taken care of. We take that and we substitute it into one of these or one of these. Like this would be easier right now to pick one of these, okay? So how about we go back to this and just call this 1 and 2. It just makes it easier to follow your notes, right? Listen up carefully, okay? If you follow the first equation and what we've done, right? Technically, if you've done it correctly, all of these equations are talking about the exact same line, okay? It doesn't matter what you multiply it by as long as you do it to the whole equation. So really, when you substitute in, you could pick this, right, or this. It doesn't matter. You should get the same answer regardless of where you substitute in, right? Sub y is equal to 4. So how about we go from here, arrow, so you can follow, right? Sub y into 3 or 4. I'll make a note. I'll just leave it like that. It'll get too busy. right? So we can substitute into 3 or 4 because it's easier. I choose 4. Okay, so x plus 2y is equal to 16. X plus 2 times 4 is equal to 16. X plus 8 is equal to, sorry, 16, not 18, is equal to 16. The 8 comes over subtracting. Now to verify using original. When it's verifying time, you want to go back to the original, because then you're going to find out whether or not you made a mistake along the way. Okay, so this is our verifying chorale here. So for the first one, I have 3 over 4x minus y is equal to 2. So it's 3 over 4 times 8 minus 4. So here you can go 3 times 8 is 24 divided by 4 is 6, right? 6 minus 2, sorry, minus 4. Is it, it must have been a long weekend, right? Anyways, 2 and 2 is there. Left hand side is equal to right hand side. Okay, so that's my first one. The second one, I'm going to break it down. I'm not doing the left hand side, right hand side, as you can tell. I think you get it. 1/8 x plus 1/4 y is equal to 2. This line represents the sides, right? So it's 1/8 x is 8 plus 1/4 y is 4. You can tell that, right? You can cancel these out. 8 and 8 goes in there once each. Same here. Or you can go 4 times 1 is 4 divided by 4 is 1. Regardless, left hand side is equal to right hand side. Therefore, 8, 4 is the solution. And now, try solving D by substitution. Use this, right? Use this side back here. See back side. Or previous page. Okay, so you should have a blank side on this side here. And what we're going to do is copy down the exact same thing. We're going to copy this thing over and start from scratch, right? I need you to be able to do that by substitution because it would still work out just fine. Okay. I don't know where you're at. I'm going to leave it there for a little bit. So we're going to take a little commercial break here. And enough of me talking. So we're going to go back. It's open book. So if you want to go, if you need to review, go for it. And so we're going to go to this page here and just write it down here. Solve by substitution. And here it's 3/4 x minus y is equal to 2, and 1/8 x plus a quarter y is equal to 2. So solve that by substitution. I'll give you some time. I'll pause and hurt having a little bit of extra time, right? Okay, solving by substitution. Let's try this. So this is a review, right, for you. The goal here, okay, no matter what, get rid of the fractions, okay? Just like with elimination, we tend to want to do the same across the board. For substitution elimination. For graphing, I will show you this as well. Graphing, we're going to review that just now. Okay, so you can start having all three in the back of your head, right? So you're not forgetting. Okay, so pretend like we didn't do the elimination. We have no idea what happened. Get rid of fractions. Okay, remove fractions. So if you've done this, just relax, right? So we're going to take this whole thing and we're going to multiply it by 4. And we get 3x minus 4y is equal to 8. And then here, we're going to multiply this by 8 in this case. So you get x plus 2y is equal to 16. Okay? And we're going to call this 1 and 2. It's better so you have a reference, okay? So we have our 4 equations now. These 1 and 3 are exactly the same. 2 and 4 are talking about the exact same line. Don't forget that. I see this, okay? I'm going to highlight that. So instead of trying to eliminate, we're going to isolate, okay? Isolate x. So we take this one and we go x is equal to, we can just take it as is. The 2y comes over, negative 2y plus 16. When I was looking over your ACs last Friday, I saw a number of you actually isolating completely. You didn't have a 3x in front, right? Like I used the 3x because there was a 3x on the previous equation. You actually isolated and it still worked out. So I was glad to see that. So this is important, right? You take one of them. This one is easier, right? Easiest to do. And then we're going to take that and substitute that into the other one. Okay? So we sub into 3. Right? Because this is from 4. We take that and substitute it into the other one. So we have 3 times negative 2y plus 16, right? We were essentially plugging into x, and then we follow with what is still there. Negative 4y is equal to 8, right? You have to have the whole equation written out. And then you distribute. That's negative 6y plus 48 minus 4y is equal to 8. You can combine your y's. That's negative 10y. The 48 comes over subtracting, so you can go 8 minus 48. So you end up with negative 10y is equal to negative 40. And it's the process and the steps that you have to be careful with, okay? So there's y is equal to 4 there. I probably should have shifted to the left to use my space wisely, but we're going there, right? So step, right, isolate. Then substitute whatever you isolated into the other equation. And now you should be able to actually get an answer for one of the variables, right? And we take this and we say sub into, you could do 1, 2, 3, 4 in a sense. You could substitute it into any one of them, but we kind of want to leave these behind. We're just going to use 1 and 2 to verify. So I'm going to say sub into 3 or 4. Easiest. Again, I should put down easiest thing to do. So I choose I choose 4. Okay, so it's x plus 2y is equal to 16. So it's x plus 2 times 4. We just found out that it's 4. That's equal to 16. X plus 8 is equal to 16. X equal to 16 minus 8. X equal to 8. Therefore, solution is 8, 4. Don't mix them up. Verified, right? Verified already. So we're not going to go ahead and do that again. Okay. Okay. I hope this made sense. I hope you know now that, right, both methods work. And this is where homework is going to pay off tremendously. If you might be looking at this right now and you're able to follow and you're like, yeah, that makes sense. Yeah, it all works out perfect. But if you don't practice this, I'm telling you, you're gonna struggle on the test. You're gonna get stuck, right? Because you're not gonna know how to proceed from there because you haven't ingrained this, right? You need to be able to think through it and make the mistakes that everybody makes, right? It's naturally to make mistakes, but then you learn from them and you know what to do exactly, how to proceed, and also how to show your work properly. A lot of the common mistakes or errors that I see is just jumping to the answer and not showing your work properly. Okay, you need to be able to show your work and see, especially if we were to do this online, I need to see the work. Okay, um, will I do by graphing? Solve by graphing. I think I will. This one is probably not the best one to do by graphing, but I want to show you that it works. Okay, so let's copy this down just on that same page. If you ran out of room on this page, take another blank one from here, right? Just go somewhere in the previous pages, right? Go back a few pages and just write this one down. Solve by graphing. Just copy this down, because even if you forget that it's connected to what we already did, you will have that system there written down. Okay. All right. So we have that. Normally, I would tell you get rid of fractions, right? Normally, I would tell you that, and you wouldn't be wrong, but you would actually have to do double the work if you did that when it's graphing time. What we want to do is rewrite into y is equal to mx plus b. That's what you want to do. It's the slope intercept. That's what we want to do. So make sure you write this down because it's been a little while. And no question, there are no two questions that are the same. Okay, so this is where your algebra skill. Okay, Christian, I see that you're there. I will mark you here. Okay, so you got to follow here. Follow. It's algebra, 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 right? That's what it really comes down to. So we're going to take, I'm going to label these 1, 2, these are my original. And I'm going to go ahead and rewrite them. Not here because it might be too busy there, so I will just do it here. And I will keep this area here for my graph, okay? So don't use up this area here where my pencil is hovering. So the first one, I'm just gonna go negative y already. I'm just gonna copy this negative y there, is equal to, the 3/4 x is a term. If I bring it over the equal sign, it changes signs. So it comes over negative 3/4 x, and the 2 is already there, positive, so we add it on like that, plus 2. When you have negative here, we want to either divide or multiply the whole thing by a negative, by -1. So I'm just going to take this whole thing and multiply it by -1. And that really just changes the sign of everything. Don't forget the x, okay? A lot of you are dropping it, okay? -2. So there is my slope-intercept. So start at 0, -2. And my slope is 3/4, and it's positive, so I expect my line to increase from left to right. Okay, done. Not too bad, is it? Okay, and then we're going to do, we're going to work with our second one, second equation. Let's break this down. It's better to have lines so you're not mixing things up. Okay, so we're going to work with this one up here. Whoa, what's happening there? Don't worry about it too much. We have 1/4 y is equal to, I'm going to bring the 1/8x, it's a term, and bring it over to this side. So it comes over negative plus 2. Right? And now I'm going to multiply this whole thing by 4. Okay? You could have put a /4 here, a ×4 there, but it's really, you're doing that to the whole thing. So that ends up with y is equal to -4/8x plus 8. Let's reduce that fraction. A lot of you miss things like that, right? You got to reduce that fraction, right? And so start at 0.8, and your slope is -1/2, and which is going to go downwards from left to right. And I'm telling you this because you're going to be graphing this at home for ACs and whatnot. If you use a scale of -10 to 10 and then -10 to 10, like going 10 in each direction, you will be fine. So let me try to make that work. That's going to be the challenge, right? So you just got to use a smart scale, I guess. And so this is X and Y. Okay, so I'm going to try to fit in 10 here. So 1, 2, 3, 4, 5. Make sure you just space them equally, right? 6, 7, 8, 9, 10. That worked out. Do the same thing going in each direction. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. -5. I know that I'm going to be okay back here, so I'm not going to, because we know that our solution is 8,4, right? But we won't always know that. -5. 2, 4. This is 5 here. 2, 4. This is -10 here. Okay. Make your grids. I will pause a bit because I want you to follow because it's right. I'm assuming your grids are all done. Okay, let's start with the first one. 0, -2 is right here. And then I'm using a slope of 3/4. So 1, 2, 3. It's always rise and then run. 3 and then over 4. That puts me right there. And then I'm going to do another 3. 1, 2, 3. Over 4 puts me at 8 there. And I know that it's challenging graphing without a grid, but it's what it is, right? You would label, right, using any one of the equations here. You could do 3/4 x minus y is equal to 2. I'm using the original. And then I'm using the next one. 0, 8 signs are very important, right? It ends up being positive 8, so I'm here. Start here. And then I'm using a slope of -1/2. So 1, 2. I kind of try to line it up with my marks, okay? And it's 1, 2, and so forth. Look at that, it actually works out. You have 1/8 x plus 1/4 y is equal to 2. Don't forget your vertical and horizontal lines. Systems have, it's rare that a system does have it, but don't forget it. And so we need to have our point of intersection, which is 8, 4, and we already verified. And I'll just make a note here, already verified, right? So you're not thinking, oh, this example didn't have it, so don't worry about it, right? Verification works the exact same way across the board. Any method, right? It always works out to be the same. I think I'm just gonna mention one more thing. If you do the homework, you should have already done the homework that I assigned on Friday. I know it was a long weekend. I know a lot of you had much better things to do than worry about homework. I understand that, but you need to have a few of these done on your own. Okay, go through the questions and maybe pick a harder one. Don't pick the easiest one. Um, give it a try, give it a go. It is very important, or else you're gonna feel overwhelmed if you just wait a day or two before the test and study hard, right? You're gonna feel overwhelmed. So what I want you to do is, let's go back to where we sort of um, broke off and kind of took a break from this elimination method. I will put a star on this. I will do that as time allows. We're gonna the answers are really messy here. It's fractional answers, which is to, like, you should be able to do that. I'm just gonna put a little pause on that because we've done a lot of elimination now. I will say here, homework. This is review all methods. So if you're up to date, this is where I would like you to go. Page 441. This is a reviewing in the textbook. And I want you to do question 1 and 4. Um, I will just make a note. Remove decimals by multiplying times 10 times 100, etc. Okay? So there will be questions that have decimals that should not throw you off. Just multiply everything by 10 or by 100. It depends on what the highest number of decimals would be in that scenario. So I haven't done an example, but you should be able to do that. Okay. Let me just see here. And then tomorrow we'll do the lovely word problems. Okay. I I think tomorrow I will definitely have an AC on everything we've done so far, which is basically the three methods, right? And so be prepared for that. Okay.